So we have resonance structures, and you learned these before. It just basically means that a structure's bond can flip to a different atom that you drew. But in reality, molecules, they don't say like my double bond's here right now, and then in a moment my double bond will be here because you're drawing it there. It's just that in reality the molecule is sharing those electrons all of the time. It's kind of a constant sharing of those electrons between the atoms that they're sharing them with. Except when you draw structures, you can choose to put your double bond here, or you can choose to put your double bond here, but we should recognize that there's not 2 bonds and 1 bond, but actually there's 3 bonds, 6 electrons being shared by 2 atoms, 2 terminal atoms. Did you hear all that? So it's not 2 and 1, it's actually 3 bonds, which is 6 total electrons, being shared amongst 2 terminal atoms. In just the example that I've given you, this can be in other ways also. Okay, so that's what this is basically saying. They can be located between different atoms, and then this gives us possible Lewis structures that would be different. And we have to draw them all. So ozone. If we draw ozone, we end up with 3 bonds. We can put a double bond on the left side or the right side, but it doesn't really matter. The question that they like to ask, and this is probably one of my favorite questions too, because students just need to like drill this into their heads. It is not 2 bonds and 1 bond. So if I ask you which bond is longer, which one would you say by default if you weren't thinking about this? The single bond's longer, right? The double bonds are shorter. But in reality, there isn't one that is greater than the other because it's just an equal sharing of these 6 electrons between these terminal atoms. So there isn't a bond that is actually longer. So both bonds are the same length as they each contain 3 electrons. Ozone is actually the average of these 2 structures. The effective number of bonds between each pair of oxygen atoms is 1.5. So the wording that you need to focus on for this lesson is effective number of bonds. And they will not ask you, and I will not ask you the question, how many effective number of bonds are there? I will expect you to put that in your answer when I ask you about bond length. So your specific wording must be effective number of bonds. So how did I solve that? I'll show you the equation in a second, but how did I come up with 1.5 bonds? How many bonds are there total? How many terminal atoms are there? It's 3 divided by 2. So what you're going to do is you're going to evaluate how many bonds is this structure sharing between the terminal atoms. And that tells you really how many there are. So I'm going to stress this again. You understand that it's these electrons, all of them are being shared like this. So not 2 and 1, all of them are being shared. Anytime that you have to examine the bond length of any 2 structures, you're always going to be talking about effective number of bonds. They always like that question. All right, so we have bond length and bond energy. Nitrate. How do you know that this is a resonance structure? So the first thing you have to do is be able to recognize that you have a resonance structure present. What's a good clue? Double bond and the same atom somewhere else in that structure, on the same central atom. So I'll know I have a resonance structure because I have a double bond and I have the same atoms attached to the central. So this double bond can be here or it can be here. So in this example, I have 3 resonance structures, right? And you may be asked to draw all resonance structures for a specific molecule. And you would have to draw for this example 3. So key thing, you make your structure the way you always would, make sure you put the charge, and then double way arrows indicate resonance structures between them. It's not an equal sign, don't draw an equal sign, it's a double way arrow that you draw in between each of your structures. So for this one, how do we calculate effective number of bonds? Take your total bonds, divide by all terminal atoms that they could possibly be sharing with. So how many bonds do I have? 4 bonds, how many atoms?
3.
And so effective number of bonds is 1.33. Make sense? Formate. So you draw your structure. If I didn't show you this, how many resonance structures would you recognize you have? Just the 2, because there's a double bond and there's 2 terminal atoms attached to that central atom that could possibly have that double bond. So in this example, I have 2 resonance structures, 3 bonds being shared, and 2 terminal atoms. So again, this is 1.5 bonds. So you have to use the words effective number of bonds when you're discussing this. Okay, this is the question that you'll get on the AP exam. Very similar to this. The first thing that they'll probably do, because AP questions are usually multiple parts, is they'll ask you to draw these. So they won't draw them for you. They'll ask you to draw them first, and then they will ask you which structure has the shortest bond, and it will then say, justify. So anytime you see a justification, you have to explain why. You can explain that with math, and then just use like one sentence to just discuss it, but you can't just pick one. So you always have to justify it. So how are we going to pick between these two? What are you going to use? Effective number of bonds. Good guess, though. That one's for formal charge. GU is for formal charge. So if we're going to use formal charge, that would tell us which structure is more likely. But that would be if I was drawing this structure or I was drawing this structure separately, I would check first formal charge. So Grace is absolutely right. Like if we're drawing structures, we have to check formal charge first. Then we would come up with the two of them, and then we would pick which one has the shortest bonds. All right, so take a minute and try those. All right, so which structure? Mike Stewart. Nitrate or nitrate, the top one. So effective number of bonds between this is 1.5. Effective number of bonds between this is 1.33. How many of you got that? Thumbs up. Right, so how do you determine shortest bond? You know this. If I gave you bond order, remember yesterday I taught you bond order? Bond order of 1, 2, 3 means single, double, triple. Okay, which one is the shortest? Shortest, longest, right? So if those are true, I think I need to twist this way a little bit. If that's true, then 1.5 falls in here, and 1.33 is a little bit smaller, right? So which one is the longest? The 1.33, because it's closer to being like a single bond. And 1.5 is shorter because it's closer to being like a double bond. You can think of it in that order. So the shortest bond length, then, is what Mike said. The nitrate ion has the shortest number of bonds, as the effective number of bonds between N and O is greater in that structure. Does that make sense? Most often, students will get the correct effective number of bonds, but your brain kind of plays a trick on you and you forget this. So you'll automatically just say that 1.5 must be longer because it's a bigger number, but in fact it's shorter because it's closer, the electrons are holding that bond tighter. Does that make sense? Okay. And so the last thing, it says, in some cases, resonance must be used to refine a Lewis structure in order to obtain qualitatively accurate predictions about the effective number of bonds, bond energy, and bond length. So some of the additional questions that we'll see, they'll ask you specifically about bond energy in the two different structures. So not just which one has the shortest bond length, but instead of using the word shortest bond length, maybe it says which structure requires the greatest bond energy or has the greatest bond energy. So then your brain has to think, I'm thinking shortest bonds or strongest bond strength would come from my bond length, and the longest bond length would be the smaller number, and the bigger number would be my shorter bond length. Making sense? So if I were you and I was doing this, I would probably write this down on my paper just to like get my head straight and not accidentally make a mistake by just choosing the bigger number. And that's it. So let's open up your packet of questions and we'll try one of them before we move on.